Okay, so our speaker for this afternoon is a graduate of Bachelor in Engineering with honors at the University of Malaysia, Kuala Lumpur. He has specialization in process engineering and programming, and with a subspecialization in waste-to-energy systems, combustion and incineration processes, flue gas treatment processes, and Visual Basic for applications and Python. He is currently involved with Dialog Group Malaysia as a process engineer. So ladies and gentlemen, without a further ado, please let me help me welcome virtually Wei Jian Teo. Hi
Thank you,
Wei.
Bianca. Thank you, Bianca. Can you hear me?
You're welcome. Yes, your
Yes.
audio.
Yeah. All right. Very good evening to all of you. I'm Wei Jian. You can call me Wei Jian. And I'm from Malaysia, which is a pretty small place compared to the Philippines. So before we start, I would like to first invite you guys to tell me where are you from, especially if you are from the Philippines, which part of the Philippines you are from, because to me, Philippines is a huge, huge country. Yeah, so please let me know in the chat box where are you from and which organization you are from, and let's have some interaction with each other. Yeah, please let me know. So let me just share my screen here. Can you guys see my screen, Bianca?
Not yet, Wei Jian. And here it goes.
All right, thank you, Bianca. Yeah. All right, so today's topic is a very, very interesting topic for process engineers and actually basically any chemical engineer, because this is all about solving engineering problems with a very simple tool that we all have at our disposal, and that's called Microsoft Excel. So before we start, I would like to thank PIChE Bataan chapter for inviting me. We have a huge crowd before. To be honest, this is the biggest crowd I have in my experience. I have given a few webinars, but not in such a big crowd. So please let me know if there are any trouble, any problems. Please let me know in the chat box, and I'll try my best to answer you if you have any question, because we have to have a very, very large attendee today. So just to start out my outline, I'm going to tell you a bit about my background, some common myths about what is Excel and VBA, basic syntax, and some hands-on examples. So get ready to get your hands dirty. Today we are going to have some hands-on examples. So please prepare as many questions as you have, because to be honest, outside there, if you are going to ask these questions, you have to pay for them. Today I'm giving to you free. Please ask as many questions as you have. Don't worry about me not answering them. I will try my best to answer all the questions that you have, all right? So let's use this time to interact with each other as much as possible. You can learn from me, I can also learn from you. Yeah, so first let you know a bit about me. So I'm actually from University of Malaya, which is the highest ranking university in Malaysia, which our faculty will always remind us every day. So these are some of the events that I've been involved in while in my university. And in university, I had this start to learn about programming because I was invited by the founder of this app called UniChat. So it's an app that you can find in the App Store and the Android Google Play Store, where we actually provide you with a scheduler. And this is also an app that includes a lot of what you call promotions. For example, you can go to a restaurant, you can get a 20% discount or 20% off some meals just using this app alone. And if you're a university student, you want to give it a try, feel free to download it. But for now, most of our promotions is only in Malaysia, and we are trying our best to expand outside Malaysia. So if you want to have a try, do give it a download. Yeah. And currently, I'm working at Dialog Group. So Dialog Group is an engineering company. So Dialog Group focuses on environmental technologies. And some of the things that Dialog does is like gas and exhaust treatment, high temperature technologies, and water technologies. But for me, my experience is mainly on the first two. So I'm mainly in the flue gas treatment processes and also waste incineration processes. So with emission limits getting tighter and so on, this kind of environmental technologies are gaining more and more traction in the industry. In my free time, I run a Facebook group called Chemical Engineering and IR 4.0, where we share things about what the latest innovations and trends in the industry and some help if you need it. So if you want to, if you're interested to join, please feel free to join. It's free. And on my LinkedIn profile, I do post regularly about how tips and tricks to use Python and VBA to help you solve engineering problems or even just for fun. So this is basically what I do in my spare time. So enough about me. Let's talk a bit about today's subject. So what is Microsoft Excel? So this is Microsoft Excel. And to be honest, I think most of you have seen it before. If you have used a computer, you probably have used Microsoft Excel in some point in your future, in your past or your future. And you probably know what's by now. So I'll skip the introductions, but just to say Microsoft Excel is a spreadsheet program for various calculations. And there's a wrong perception out there, perhaps, that Microsoft Excel is something used for accounting, economics, statistics kind of program. But that's not true, because Microsoft Excel has a lot of functions that are used in engineering applications. So I'm going to tell you about some common myths that people often encounter in the, people are first starting to learn about this Excel and VBA. And I think you guys must have seen this before. This is the Mythbusters show to Australians, I believe. And we are going to bust some myths today, just like that. First, Excel is only for accountants, mathematicians, and so on. That's not true. Engineers use Excel almost every day, including me. Almost every day. Programming is only for computer science students. The fact is that engineers do use programming. Of course, it depends on what exactly you are doing. Not every engineer will be programming things here left and right. But for most engineers, especially chemical engineers, knowing a bit of programming is very useful in helping us to save our time, to do repetitive tasks easily. Just one click, whole task is settled. Programming is only for nerds. Well, a lot of people think that, like Mark Zuckerberg, the biggest nerd on the planet, Elon Musk, and so on. But the fact is that anyone can be a programmer as long as you know how to use a computer or a phone. And if you are in this webinar today, I'm sure that you have passed this criteria. And finally, you need special software for programming. This means that you have to learn about this software before you can start programming. That's not really true. You can do programming in Excel. You can do programming using Notepad. You can do it using Microsoft Word. You can do it using free online websites. So there are a lot of resources and softwares that you can use for programming. But the fact is that many of us, we are not really exposed to what kind of software that is available. And that is, I believe, is a root cause of why programming is not really that, it's sort of something that is not that famous among engineers today, especially in chemical engineering. So if you even know a bit about programming, we are going to hear a lot of these terms being thrown around today. Industry of Things, Internet of Things, Industrial Revolution 4.0, Industry 4.0, and so on. And when you read into it, you are going to see a few programming languages that often appear when it comes to these discussions. So we have like R and Spark for data science, machine learning, artificial intelligence, which we are not going to touch about today because artificial intelligence is too much for us today. We have MATLAB and Octave. So MATLAB is, I think you guys know what MATLAB is engineering software for solving mostly matrix manipulations, but also for other mathematical applications, modeling for simulation and so on. Octave is a open source version of MATLAB. So if you don't want to pay the fee, you can download Octave and have a look. Java and JavaScript are for apps development, websites development. So if you are Android developer, you hear about Java development and so on. HTML and XML are what we call markup languages. In the strictest definition, they are not really programming languages. They are a subclass called markup languages. But just in this simple discussion, I'm going to lump them together as a programming language. And HTML and XML, they are usually used for websites and server applications. So if you open Google, you are using HTML. So you are searching something on Google, you're also using XML. So that's basically the language that actually runs the whole internet, basically. So after discussing all the languages, where is our language that we are going to discuss today? So where's VBA? So if you guys have any idea, you can let me know in the chat box. But I think the name alone will let you actually betray where VBA is in this table. So VBA is actually derived from the language Visual Basic. The full name is called Visual Basic for Applications. So these 4 applications is actually a key point in the name because it is actually a simpler version of Visual Basic that we can integrate inside most of the Microsoft Office applications. This means Excel, Microsoft Word, PowerPoint, Outlook, Access, OneNote, and if you have other Microsoft projects, you can also use VBA. For today's discussion, we are going to focus more on Excel because that's probably the most common application of VBA. And if you have some background in programming, I'm going to tell you a little bit about why this programming language is special. The first is that this is an object-oriented programming language. And an object-oriented programming language, you define classes. What is a class? You have subclass, you have inheritance, and so on. But for the layman like me, I'm not going to know all these things, but just to let you know that it's an object-oriented programming language. And being an object-oriented programming language is very powerful. It is as powerful as C++, it's as powerful as C, it's as powerful as Python, but it's sort of the underdog in the programming sector, I would say. And it allows for user-defined functions. I mean, I can invent my own functions. I can invent a function that gives me the density of air at a certain temperature. It can give me the steam saturation temperature at 10 bar steam, for example. I can ask it to tell me the enthalpy of oxygen at 500 degrees Celsius, for example. I can ask it to solve a thermodynamic equation for a certain condition, and I can do it easily just by keying inside the Microsoft Excel. So this is done using what we call user-defined functions. And today I'm going to walk you around a little bit about these user-defined functions. Yeah, so you can also do your own user-defined functions. So after a long-winded discussion about what VBA is and so on, when do we use it? The fact is that usually we don't jump directly into programming as an engineer, because if there are easier ways to do it, why do we use programming, right? So we don't use programming if we can solve using 2 basic Excel tools. The first is called GoSig. The second is called Solver. And if you have tasks such as repetitive tasks, complicated tasks, for example, this calculation involves like 5 steps and you have to keep repeating the steps again and again, you can use VBA. Iterative tasks, for example, this formula requires you to substitute one number into the formula, take it out, substitute again for 100 times, 1000 times, you can use VBA. So before we go into an in-depth discussion about what VBA is, I'm going to tell you a little bit about these 2 simple tools and how you can use them to solve very, very simple problems. Yeah. So before we continue, I would like to invite you guys to download a copy from the worksheet from the link below, where I'm going to use this worksheet to show you some examples of how we can use VBA in our engineering applications. And I'm going to post this link in the chat box. So if you have you might want to do it now or do it a bit later, but I recommend you guys do it now and tell me if you have any trouble downloading the worksheet, which I have the link in the chat box and also on screen. Yeah, so I'll give you guys a few minutes while you guys try to download this worksheet. It's an Excel file. So once you have downloaded it, please try to open it and make sure that it opens properly. And if you can, let me know in the chat box. If you can't, let me know in the chat box too.
Highway, I think the link is broken.
Oops, let me give you another link. Let's see. Right, guys, I think some of you guys can manage to download the link for some reason, but I'm going to give you an alternative link just in case you can't download it for any reason. So please try the second link if you have any trouble downloading the file.
All right. So the Google Drive link is working.
Yeah. Thanks, Regine. I think you posted the file on the group. Yeah, thank you very much. But if you have any trouble downloading, please let me know and I'll try my best. And if you have downloaded, please open it and make sure you can open it. Otherwise, this discussion will be pointless. Okay, if you have downloaded, I'm going to switch my screen to my Excel sheet now. So I'm going to switch to that sheet. And for that purpose, I'm going to stop my webcam because it's causing some lag problems on my side. So don't worry, I'll show my face later on if you really want to see it. And I'm going to show my Excel sheet now. So let's go to that sheet and have a look at what we are going to do later. Okay, so the first thing I'm going to tell you about is GoSeek. So GoSeek is an application that you can find inside Excel. So I think some of you guys will probably have known what is GoSeek, but just a small discussion on that. So let me share my Excel screen now. All right, so I would like to ask you guys if you can see my Excel file. So I've just opened the file that I sent to you guys to download, and you should be able to see exactly the same thing as you are seeing on my screen. Please let me know if you can see my screen. All right, thank you very much. I think many have been able to open the screen. All right, so what I'm going to show you now is what you call GoSeek. So GoSeek is actually a very simple application to use. Firstly, you have to find it. And so for demonstration purposes, I'm going to show you using Excel 2016, which is the newest Excel, I believe. If you have a slightly older version of Excel, it will look a bit different. So I'll give you some time if in case you can't find it, let me know in the chat box. Because some of you might have older version of Excel. I believe the oldest that you can find is Excel 1997. So I'm not sure what Excel versions you have. So I'm going to show you on the screen that please click on the, it should look like this at first. Please click on the data tab and you have here what if analysis. Click it and you'll find GoSeek in the drop down menu. So let me know if you cannot find GoSeek. Let me know if you cannot find GoSeek. If you can't find, you can have a click. And this is basically GoSeek. Just a dialog box with 3 inputs. This is the function, but it's very powerful. Don't be distracted or don't underestimate this tool. It's very powerful. So I'm going to show you what exactly it does. So let's say I'm going to have an equation. Let's not go into the example 1 yet. Let's say I have an equation, x plus 2 equals to 4. So what is the value of x? So some of you guys might say, hey, this is easy, right? The answer is 2. But what if the function is something more complicated than this? Then it's not that easy to solve it. So what I'm going to do is I'm going to show you how GoSeek can be used to solve these kind of functions. So I'm going to give a cell. This cell, I'm going to define it as x. And I'm going to give a value of 0, just an initial value. And this I'm going to define as the function, x plus 2. And I'm going to give it a formula, x plus 2. So now you get 2 as a value. And now I'm going to click on this cell, which I'm trying to find. Click on what if analysis, GoSeek. And you're going to see three values that I have to fill in. So the first value is set cell. So this cell is, I want it to be 4. So I'm going to click on this button and select this cell. All right, so you're going to see that I have selected cell as L7. And to value, I'm going to put my target value, which is 4. And by changing cell, I'm going to select the cell that I want to change, which is the cell containing the value of X, which is this, this cell, L6. And then I just click on OK. So I get the answer 2 inside the cell containing X, and I get the target value of 4 inside the function that I want to, inside the equation that I want to make it equal to 4. So this is a very, very simple introduction of what is goal-seek, and it is very, very powerful. So you might be thinking, but Wei Jian, this is a very theoretical demonstration. How does it help us, right? So let me go back to the slides, and I'm going to show you what is the problem that we are trying to solve today. So let me just go back to my slideshow here. All right, so just before we start, a rule of thumb is that goal-seek is as simple as A, B, C. As simple as that. It makes A equal to B by changing C. Yeah. And these are the ABCs that I'm meaning, which is the first, second, and third inputs in the dialog box. So A, B, and C. So there are some rules about what I can put inside A, B, and C, of course. A must be a function. B must be a value, usually 0, but can be other values. And C must be a cell reference. That means C cannot be a value. C must refer to some cell. So it is a cell that I want to change. So let me start with a question that will probably remind you of your university days. If you are a student, it will remind you of your probably current university days. And let's say we have this guy called Steve here. So Steve is a chemical engineering student at the University of VBA. I'm not sure where university is there, but let's just pretend it exists. He's worried that he will fail this semester. Help Steve find out how many marks he needs to get in the thermodynamics exam to pass. So we all know thermodynamics is the most difficult subject, right? I believe most of you guys will agree. You remember your university life, thermodynamics is the most difficult subject. For me at least. I'm not sure about you guys. So now he wants to know how many marks he must get in thermodynamics in order to get an average score of 60. Sounds easy, right? You can just take out a calculator and press it. But that's not the point of today. So let's see how we are going to do this question inside Excel. So let me go back to my Excel sheet. And I'm going to show you guys how to do it. All right, so I think my Excel sheet is now visible. So you're going to see this example 1 here. So I've prepared for you the question and the values that you're going to use it, so you don't have to type it again. And you can see that I have already provided the score for the first 4 subjects, 1 empty subject here, and the average. So I've calculated the average of the 5 subjects. So what I'm going to do now is I'm going to make this average at least 60, right? So I'm going to click on the average cell, click on what if analysis, goal-seek. So I'm going to see this dialog box again. So I'm going to set cell E16 to the value 60. So I'm going to type in 60 here. By changing cell, I'm going to select. You can click on this button, or you can just directly click on this side and select the thermodynamics cell. So let's just click OK. And you find that you get the score of 75. So that is what we want. Yeah, so this is what we want. So if you have any trouble getting the result, please let me know in the chat box. I'll try to solve that problem for you. And if you are okay, you can try many other values. You can try to get 70, 80, 90, 100, and so on. And you'll find that goal-seek will always give you the correct answer for this question. Yeah, because this is actually a very simple calculations. All right, so I see there are no questions for now. Repeat steps. I think Nadeep, you're asking me to repeat the steps. All right, so let me just show it once for your benefit. So first click on the average cell. That means this is a cell that I want to be equal to 60. Click on this cell, click on what if analysis, click on goal-seek. And this dialog box is going to appear. So in the set cell, here I'm going to put this cell, which is already selected. But if I want, I can just click again. Sorry, just click again. To value, I'll key in 60, which is my target value. By changing cell, I'm going to put in thermodynamics 1, score inside thermodynamics 1, and click OK. And it will give me the answer inside the thermodynamics 1 cell. Now, does that answer your question, Nadeep? Okay, I hope. All right, thanks, Ganadeep. I hope you managed to get it right because we are going to use it a lot later on, a lot of times. So let me just go back to my slides and I'm going to show you what is my result that I am supposed to get and see if I can get the same results. So you can see this result here. And let me just show you. So this is A, B, and C. So I'm going to make the average of 5 exams equal to 60 by changing the thermodynamics score. So I should get the correct answer of 75 inside the thermodynamics box, and I will get the average of 60 inside the average score. So this is basically what is goal-seek in a nutshell. Yeah, so well, you might ask, Wei Jian, you have shown me what is goal-seek, but how does it apply in engineering applications? So the next example is going to show you some engineering applications. The first is that goal-seek is very useful as an equation solver, provided that you can write the equation in the form something equals to 0. You can, if you think a bit, you realize that this is true because if I can let any cell equal to 0 and I adjust one cell, just one cell to achieve this 0, I can solve the equation. Yeah. I think in a college or university level maths course, usually we write equations in the form of something equal to 0 and then we solve it, especially in the form of polynomial equations. So simple is still using the same A, B, C. A is a cell containing a function, B equals to 0, and C is a cell containing the unknown that we want to solve for. So let me just go back to my Excel sheet and I'm going to show you how I'm going to use this for equation solving applications. So let me just share my Excel screen here. And as you can see, I finished example 1. So I'm going to go to example 2 now. So you can see 3 equations here that we are going to try to solve using goal-seek. Right. So let's see how I can do that. So the first equation is written here. So actually, I want this equation to be equal to 0. So I'm going to fix it here. And I'm going to use this cell, this green color cell as x. And I'm going to write the function here. So this is actually x squared minus 4x plus 4. So I'm going to write in x squared minus 4 multiply x plus 4. So I'm going to get the value of 4 because x is actually 0, right? And then I'm going to make this function equal to 0 by clicking what if analysis, goal-seek, set cell equal to 0 by changing x. So you're going to get the answer of 1.974.22. So this is the first thing I want to show you. If you go back to my slides, you're going to see that I just said precision matters. So the correct answer for this equation is actually 2. So if I type in 2, I get 0 exactly. So the precision matters because I started with a value of 0. So let's say I will put in an initial value of 1 and I try to do the same thing again. Sorry, let me select a correct cell by changing this. And I'm going to get a different answer, slightly different answer. So the reason why this happens is that goal-seek is a numerical method. And numerical methods for solving equations sometimes do not give you the exact answer. It gives you the answer that is very close to the exact answer, but it doesn't give you the exact answer. So sometimes you do have to adjust and try your best, try a different starting value, let's say 10. And we are going to see if this time it gives us a correct answer. Set cell to value 0 by changing cell, this one. So you can see it gives us an answer of 2.02365. So that's very close to the exact answer of 2. So the exact answer in this question is 2. Yeah. So you can see that there is some error, and you can change this error by going to the Excel options. But for now, I will recommend not doing that, and because we are going to finish this examples first. And just for your knowledge, right, I have the answer written in here, but it's just in white. So if you can see the answer by clicking on this cell, yeah. So just in case you want a reference. So let me just go through the next equation. So the equation is written as x squared minus 3x equals to 6. But we want the equation to be equal to 0. So we can just do a little bit of rearrangement so that we move the 6 to the left side and we get 0 on the right side. And I'm going to code in this equation here. Again, the same way as the last equation. Minus 6. Oops. Let me just try that again. Minus 3x minus 6. Okay, so I get this equation correct. And I'm going to try and go seek to see if I can get the correct answer. So I'm going to click on this function cell, go seek, set cell to value 0 by changing this cell. So I'm going to get the correct answer, which is negative 1.37228. So I'm going to review the answer here. So this is the answer. And all right, so I'm very happy I got the answer correct. But if you remember your high school or your university or college level class, you are going to realize one thing. This is not the only answer to this equation. There are actually 2 answers to this equation. And the second answer is probably a positive number. Looking at the function, the second answer is a positive number. So it gives me a negative answer. What can I do, right? So this comes to my second point here, which is the initial value matters. Let me just delete this and give it an initial value of negative 5. And I'll try the go seek again. I'll just try the go seek again, but with the value negative 5 placed in x. So I'm going to do go seek to value 0 by changing this cell. All right, so it gives me the answer negative 1.37 as expected. What about if I start with an initial value of 10? And I'm going to do go seek again. You realize that it gives me now the positive root of this equation, which is 4.37. So I'm going to review the answer here. So this is the positive root. And you can see that the answer is not exactly the same because it has some inaccuracy in it because it's a numerical method. So in order to be very smart in using GoSeek, you have to roughly know where the answers are. At least you must know, is the answer positive or negative? And if you can, try to narrow a range when you know the answer is, maybe you know the answer is between 1 and 100. So maybe you can start with an initial value of 50. Or you know the answer is between negative 0.1 and negative 0.2. You can start an initial value of negative 0.1. So that's how you use the GoSeek properly. Otherwise, it might not give you the right answer. Yeah. So let me just try this third equation. So we have exponent x. So again, I'm going to write it in the form equal to 0. And I'm going to code the equation here. So exponent can be written by typing the function exp, open bracket, select the Excel, minus 3.2.3564. And I'm going to just do this again. And go seek. And it gives me the correct answer, which is 0.8576. But you realize that as I show you this answer, the answer is not perfectly the same. Let me just go back. You can see the answer has slight differences, and this is because, again, it's a numerical method. It doesn't give you the correct, perfect answer, but it gives you an answer that in most cases is good enough for the equation that you're trying to solve. So if you guys have any trouble using GoSeek, let me know in the chat box while I go back to the slides and show you what I expected. All right, so you can see that I have shown the answer here actually. So I've done it and I can show you the answers. So just a few tips and tricks before we go on. Most equations can be solved if they are written as fx equals to 0, which means the function is equal to 0. You can solve the equation. GoSig only solves for one unknown, which means that if your equation has two unknowns, then sorry, you can't solve it using GoSig. You have to use another method. Number 3, initial value matters. So usually if you have an initial value that's closer to the root or the solution, it will give you the closest answer to that initial value. So if you have 3 answers, you might need to try different initial values, extremely high, extremely low, negative, 0, 1, 100, 1000, and so on, to get the roots that you want. And number 4 is the precision matters, because sometimes it will not give you the very accurate answer. So if you need a more accurate answer, later I'm going to show you a trick that you can do. All right. So I think, let me see in the chat box if anyone has any trouble. So Alphonse says, this is so amazing. I wish I had discovered this sooner as an engineering student. Yeah, that's true. Even I feel amazing. And what motivated me to give this talk was that I realized that in engineering, we use a lot of these things, but my lecturer did not teach me, basically. I had to learn this one outside the workplace. And I thought, well, why don't I just share it with you guys? So you guys don't have to go through the same thing as me, right? So yeah, today I'm going to show you this very simple tool, which is GoSig. And I think before we go on, I think I'm going to take a few questions, just to tell you a bit about what are applications in GoSig. So if you're a college or university student, most math homework you can just cheat by finding answer using GoSig. You can do finding without the need to program in numerical methods such as a Newton-Raphson method, or I think bisection method, or golden search method, whatever method that you use. You have to take some time to program that method into Excel or some other program, or MATLAB, and so on. But with GoSig, you don't have to. Just type in the equation and magically the answer will come up, right? So in engineering applications, there are a few equations that need to be solved iteratively. This means that you need to have an initial guess for the answer, and you need to use this initial guess to find the next iteration, substitute the iteration again into the equation, get a second iteration, put it again, third iteration, fourth iteration, fifth iteration, until the answer is constant enough for a certain tolerance of error, then you can say the answer is correct. So in this case, I show you the Colebrook equation for friction factor, which is used in piping engineering. In some cases, you use it to calculate the pressure drop in any length of piping. So this equation here is the Colebrook equation, and you're trying to find the value of F. You're trying to find the value of F. But the problem is that you have the F on the left side of the equation and F on the right side of the equation. And if the equation is in this form, you cannot separate out the F. You can't really solve it directly. Yeah. But what I can do is I can move the right-hand side to the left-hand side equal to 0. Just let one cell be F, and then I just go seek for the F, the value of F. That's it. Magically, I get the answer. Yeah, so this is solved. If you are a piping engineer, I hope this tip helps you. But again, not all piping engineers will use the Colebrook equation. Some will use other methods that are not this difficult. But this is one way to solve the Colebrook equation easily. We might have the Ergun equation for pressure drop. So this is for, I think, fluidization application. So if you are designing a fluidized bed reactor or boiler or these kind of things, then you might need the Ergun equation. And it uses the velocity, which is dependent on the Reynolds number, which is dependent on the velocity, and so on. So you need the initial value for the velocity. Some heat transfer correlations, for example, heat loss calculations in insulation. So you have a length of piping. You want to know the heat loss. You need to know the surface temperature before you can calculate the heat transfer coefficient. But the surface temperature is something that you don't have. You have to assume a certain temperature to get the heat transfer coefficient and then iterate again and again. So this can be used to solve that. Acid-base equilibrium. So let's say you have a diprotic, triprotic acid, or you have some carbon capture system, amine capture in natural gas processing. You need to calculate the acid-base equilibrium. You can use GoSig just to make it easy for you. Finally, cubic equation of state, which is like the Pang-Robinson equation or the Swarth-Redlich-Kwong equation, where you have to solve for the compressibility factor, or Z, of a gas. You can use the GoSig to find the answer easily. Yeah. So I'm going to go into a real life application that this actually is quite similar to a real project that we have, but I'm not going to give you any details just not to leak our company secrets. So I'm going to show you, this is a photo of a steam turbine for power generation applications in, let's say, a refinery or petrochemical or an NGL plant, natural gas liquefaction plant. And gas turbines usually produce a lot of flue gas because this is how they work, thermodynamics application. And this flue gas usually contains a lot of carbon monoxide and nitrogen oxides emissions. So this is regulated. So in many countries, this is regulated. You have to keep it below a certain amount. So there's one way is by treating it with a catalyst. For example, the SCR process, which is called selective catalytic reduction. And this process will actually convert the CO and the nitrogen oxide into harmless nitrogen gas, water, carbon dioxide. So, but because the temperature of flue gas is usually too high, we need to add in some quenched air. Some plants use water, but most plants will use air because it's cheap. And you add this to cool down the flue gas to a suitable temperature for the SCR reaction. So let's look at this graphic we have here. So this is actually the SCR reactor. And the flue gas comes in here. And we have some kind of quenched air injection to cool down the flue gas before we go into the reactor. So again, we meet Steve. He's now an engineer in a refinery. He's trying to design a quench system. And the plant manager specifies that the flue gas must be 15% oxygen, mole fraction. So determine how much fresh air needs to be added. So we are going to assume that you have a certain amount of flue gas with a certain composition, which is 5% oxygen, 75% nitrogen, 20% CO2. And we are going to add fresh air into this flue gas to get 15% oxygen by mole fraction. Yeah, so this is a very simple mass balance calculation. But if you want to do it by pen and paper, it does take quite some time. So we can just use GoSig and solve for the amount of air we need to get 15 mole percent. So let me just go to my Excel and I'm going to show you how to do that exactly. All right, so I think you should see my Excel screen now. And we are going to go into example 3. All right, so I prepared the sheet for you, but the calculations are not provided. So let me just type in the calculations here. So fresh air I can assume to be 21 mole percent oxygen, 79 mole percent nitrogen, and I can calculate the kilomoles per hour from the mole fraction multiplied by the total number of moles divided by 100. Sorry. And I can calculate the kilograms per hour from the mole multiplied by the molecular weight. And finally, I can calculate the weight fraction from the mass flow rate divided by the total mass flow rate multiplied by 100. So now it's currently 0. So let me just put in one value just to make it look nicer. All right, so I'm not going to go into how much of the details because I think you guys know it more than me. So I'm going to do the same thing for this second example. So I'm going to end up by the molar values. Same with nitrogen. End up with carbon dioxide. Create the mole fraction. Let me just set this cell here. And I'm going to calculate the weight by multiplying the flow rates. And I'm going to calculate the weight fraction. So if you have any trouble knowing what I just did, or it looks a bit confusing to you, let me know in the chat box. But I'm just doing very simple mass balance calculations using weight fraction, mole fraction, mass fraction, molar flow rate, mass flow rate, and so on. So if you have any trouble calculating, let me know in the chat box. And I'm going to guide you or show you again how I calculated all the values that I just typed in. Yeah. If you don't have a problem, then I'm going to show you exactly how to do that using GoSig. So you can see that I prepared a cell called final O2 content, mole percent. So in this cell, I actually link it to the final flue gas mole percent of oxygen. And I want the target to be 15. So I'm going to click on this cell. data, what if analysis, go seek, set this cell to the value 15. By changing cell, I'm going to change the fresh air flow rate. So please don't select the wrong cell because you must select a cell reference that is not a formula. It must be a value that you type in. And I click on OK. So you should get the correct answer of 19,640 kilograms per hour. Do not be alarmed if you don't get exactly the right answer because again, GoSeek sometimes does not give you exactly the correct answer if you use a different initial value than me. So I typed in 1 just now. So if you don't get the correct, exactly the same answer as me, don't panic. Your answer is correct. It's just that your answer is not that precise, so don't worry too much. So you can see that I have reached 15% of oxygen in the flue gas. So let me know in the chat box if you have any trouble doing that. And otherwise, I'm going to continue with a few simple manipulations using this example before we go for a short Q&A session, perhaps. All right, so let me just go back to my slides. And I'm going to share my slides again. Okay, so I think you guys can see my slide now. And so just now I just show you how I fill in the 3 values in GoSeek. And I make the final O2 content 15% by changing the fresh air flow rate. And I get the answer. So let me know if you have trouble getting the correct answer. Otherwise, I'm going to continue. So yeah, please let me know if you have any trouble. All right, so just now I mentioned that we can use this to solve equations by setting the target equal to 0. In this case, can we do it? Yes, we can. We can just create a new cell, which is the final auto content, subtract with the target, equals to this cell, set this cell to 0. I can do that, it's the same, it will give me the same answer. But in many cases, this is easier to do because I can just change this target value and I don't have to keep typing it in this value. So I can change it many times. I can change it to 10, 5, 20, 30, 40, and so on. Yeah, so this is one way, another way to do it. So what if we add water vapor instead? Calculate the amount of water required to reach 10%. So let's say Steve decides that air is too much. Let me try to add water instead. So we are going to assume the same flue gas as previously. So let me go back to my Excel. Right. So I'm going to go into example 3B. So this is how much water vapor is required. So I fill in all the calculations for you. So don't worry. And so I'm going to do the same thing. I'm going to click on this cell, go set the value to 10 by changing the water flow rate. So this is water vapor, yeah? This is not liquid water. So I should get the correct answer of 817.2 kilograms per hour of water vapor required. So if you have any trouble getting this answer, let me know. Maybe you have just typed something wrong. And this is pretty straightforward. So this is just another application of GoSeek. So I'm going to go to my third example, which is going to show you the limitations of GoSeek. So we have just finished example 3B, and we can just get the answer via GoSeek again. But what if we add both air and water instead? Calculate the amount of air and water required to reach 15% oxygen and 10% water mole fraction at the same time. So we are going to assume the same flue gas as previously. So let me just go back to the Excel and we go to example 3C. And I'm going to show you this new situation where I have to achieve both 15% oxygen and 10% water vapor. So now I've already filled in the answer for the 10% water vapor. So you can see I've already achieved 10% water vapor. So let me just try to get 15% O2 to value 15 by changing overall. So this is the fresh air flow rate, yeah? And click OK. So I get a new answer. I get 15%. But the problem is the water content is now not 10% already. So let me just try it again. Let me set this to 10% and change the water flow rate. So now I get 10%, but my O2 content is no longer 15%, right? So how I'm going to solve this problem? So the problem now is that when I change one of the parameters, it's going to change the other parameter as well. changing the fluid of water changes the O2 concentration. Changing the fluid of air changes the H2 concentration. It's an endless loop. Like I'm not never going to finish it unless I do it 100 times maybe. How do I solve this problem? So if any ideas, let me know in the chat box. How do you think you will solve this problem? You cannot be trying it 100 times, right? Try to solve the first one, second one, first one. You cannot be trying it repeatedly. So there must be an easier way to do that, right? So the simple answer is you can't. The simple answer is you can't. Because remember, goal-seek only solves for one constant, one value. Only one value can be solved at any one time. But the keyword here is only. Only. Goal-seek itself cannot do that, but something else can do that, which I'm going to show you later. Yeah. So let me know if you have any ideas about how to solve it. But just before we jump into the next topic, which is a solver, let me know if you have any questions on goal-seek. Please let me know in the chat box. And Bianca, are you there?
Yes, Weijan.
Yeah, can you help me read out the questions that I have? I think probably we have a lot of questions I see in the chat box, but I can't see them. Yeah, so please let me know if any questions and I will answer them for you now. Thank you very much.
So from the chat box, we have a question. How would we know if the answers are correct? Should we rely to statistics?
Sorry, I can't hear you. Can you repeat that, Bianca?
Hi, yes. We have a question from the chat box. How would we know if the answers are correct? Should we rely to statistics with R raised to 2?
Thanks, Bianca. That's a very good question. How do you know your answer is correct? I'm just going to say that if you achieve the target value, your answer is correct. That's all. That's what goal-seek does. It doesn't tell you, for example, there might be 3 possible answers for this equation, and you get one answer, it's going to tell you the answer is correct. So goal-seek is limited in the fact that you don't actually know if there are other better solutions that can be considered, but it only gives you the answer that is closest to the initial value that you put inside the cell to be modified. And do remember that if you leave the cell empty, it is the same as 0. So if you leave the cell empty, it is assumed to have an initial value of 0. So even if you leave the cell empty, it doesn't mean that you have no initial value. Sometimes 0 is not the best way. You might have to put in 1000 as an initial value if your answer is very big, for example. So the simple answer to this question is that you don't really know if this is the best answer, but you do know that this answer will satisfy the equation to a certain amount of tolerance of the error. So you can decrease the error. Later, I'm going to show you how to decrease this error, but just for now, just let me know if any other questions regarding this. Thanks, Bianca. Do you have a next question?
All right, thanks, Weijan. I hope that answers Jesse's question. So for our next question, here it goes. How do you define the step rate in goal-seek?
Thanks, Bianca. How do you define the step rate in goal-seek? Goal-seek is fixed. If you try for 100 iteration steps, 100 maximum. If you cannot get the answer in 100 iterations, it will just tell you that it has failed. And it will give you the best answer that it can give you after 100 iterations. And you cannot change that, it's hard-coded. So if you want to do more than 100, you have to manipulate the equation in certain ways to make sure that you can converge to the answer in 100 iterations. Yeah, I hope that answers your question.
All right, so Art, please let us know if that answers your question. As of now, I am not seeing any additional questions or clarifications.
I think I found one, Bianca. Let me see. From Julian Rui, I think. He says, what about 3 or 4 solutions? Maybe a solution is between other 2 solutions. Well, let me answer this question. That's a very good question. And as I mentioned, how do you know that you have collected all the solutions? The answer is you can't. For goal-seek, you have to try various initial values, positive, negative, 0, and so on, and to see that if you can get multiple, unique solutions. And so it helps to know if you must have an idea about where the solution is. If you completely have no idea how the answer is going to be, GoSig might not give you the answer that you want. For example, your equation is not supposed to have a negative answer, but GoSig tells you a negative answer anyway. Yeah, so it helps to have a picture of what you think the answer is going to be before you actually start running it. I hope that answers your question, Juliandri. Unfortunately, I don't have a better explanation for this, but this is the limitation of this tool. Yeah.
All right, Adrian. We have another question. It's from Charlie. Is it possible to have no solution?
Is it possible to have no solution? Charlie, the answer is yes. And I can tell you in a real life engineering application, you are going to face that a lot of times. You're probably going to see no solution more than having a solution. And the reason usually why is that you coded the function wrongly. That's what I can say. GoSig does not give you a complex solution. So let's say if you have an equation that, let's say a polynomial function where the solution is a complex root, it will say it has no solution. So that's one major case where you have no solution. Yeah, so that's the limitation of GoSig. I hope that answers your question.
All right, thanks, Regent. Charlie, please let us know in the chat box if that answers your question or if you have a follow-up question. So, okay, thank you, Charlie. So for those asking if the copy of the slides or the recordings will be sent, I think the organizers will be sending it through your registered email addresses.
Thanks, Bianca. Are there any other questions? I'm scrolling quite a lot up here and I see, okay, can't find any other questions for now. I see, Reggie, you mentioned that it only gives you one root. You can start iteration from negative number and get negative root, positive answer to get positive root. Yes, that's correct. That's what I did just now. And Eldrin, you mentioned a few applications like the Peng-Robinson equation of state. Yeah, that's true. That's one application of this GoSig. So Bianca, can you help me see if there are any new questions? Otherwise, perhaps we can continue.
There are no new questions, Wei-Jian. So I think we could proceed with the next topic.
So thank you very much, guys. You guys are very active. So please let me know if any new questions coming up, if you have not thought of it. But for now, I'm going to show you the next evolution of GoSig. I would say that, the evolution of GoSig. Yeah, so let me go to my next slide. Okay, my slide is not moving. Okay, so the big brother of GoSig is solver. However, this is a very major point that I want to tell you. Let me just turn my highlighter here. It does not solve equations. It does not solve equations. Solver itself, so the name is a bit misleading here. Solver is a tool that is used for optimization problems. That means you need to find the maximum, the minimum, or the value, or a certain value of a function that depends on the problem has to depend on three categories of inputs. The first is the objective function. The objective function is what you're trying to solve. So basically, I would say this is what you're trying to solve. The second is what you call inequality constraints and equality constraints. So I think a few of you guys mentioned about constraints in the chat box. But constraints have to be formulated in a certain way. And this certain way is a bit difficult for if you are new to solver. But I'm just trying to my best to show you how to get this solver to work. So we have one optimization problem that I'm going to assume Steve again. He is now a fuel blending engineer at a refinery. So let's say he's now producing petrol or gasoline if you're in the US for selling. And you need to meet certain specifications. And you need to determine how much of each component needs to be blended. So we have these specifications. We want as cheap as possible. We want the raw number to be more than 95. lead content less than 0.2, density more than 750. So we have 3 different fuel sources and we want to blend it together. And this is a kind of question where we will use solver to solve this problem. So we are going to do a few assumptions, otherwise we can't really solve this problem. We are going to assume that all fuel properties are linearly proportional to the volume fraction. That means I can write down each of the functions, each of the constraints as a linear equation, where the mole factor volume fraction is multiplied by the individual values to get the total sum. Yeah, so I hope you understand this equation, this assumption here. And x1, x2, and x3 are the blending percentages of volume fractions, and they should add up to 100%. So we are going to formulate the problem in solver. So I'm going to show you how I'm going to do it here, but later I will directly demonstrate inside Excel, where we have to fill in all the required things inside the solver dialog box. Let me just jump to my Excel a little bit. Right, so we are in example 4 now, pretty fast. So we have this blending optimization problem. I have all the values written here. And these 3 green cells are the cells that I want to solve for. Yeah, so these 3 green cells are the cells that I want to solve for. And I'm going to go to my solver. So solver is under data. Click on the data tab on your computer, on your Excel, and then click on solver. So one question you have is, wait, Regent, I don't have this solver button here. So how many of you do not have the solver button under the data analysis tab? Please let me know in the chat. I believe some of you cannot see this solver button, this option under the data tab. If you can click on it. If you cannot, let me know in the chat box. Some people will not have the solver, and I will tell you how to just enable this, function inside Excel. So if you manage to have solver, let me just click on this button. So it's going to show you the screen, the dialog box that I just show you inside the slides. And this is the objective function. This is the variables to be changed. And these are the constraints. So let me just set the objective function to the fuel cost, which I'm going to minimize. So I'm going to click here. And here I'm going to choose min, which is the minimum. I want to minimize it. By changing variable cells, I'm going to select here. And I'm going to highlight the 3 volume fraction boxes. And then I'm going to, subject to the constraints, I'm going to add in the 4 constraints that I just defined in the slides. The first is, let me just click add. The raw number must be greater than 95. So I'm going to click cell reference here. Change this to greater than 95. Add. Let content less than 0.2, less than 0.2. Click on add. Density more than 750, add. Total volume equal to 100. Then the last one, I'll click OK. And then I just click on solve. So I'm going to not change this. I'm going to put this on simplex LP. Later I'll explain what it means, and I'm going to tick this. Later I'll explain what it means, and then I just click on solve. So I found a solution. And it says, oh, solver found a solution, all constraints and optimality conditions are satisfied. So this is one solution. The real solution that I'm going to show you, one solution I'm going to show you is 46.11111. So that solver does, so in this case, actually this problem has multiple solutions. So this is one of the possible solutions. This is also one of them. So let me know if you find any other solutions, because it depends on what is the initial value in these 3 boxes. Yeah, it just depends on what is the initial value you have inside the 3 cells that to be changed. So in case I put 0, I will get one solution. If I try another starting value, maybe 100, I will get another solution. Yeah. So let me know if you have any trouble getting it. Right, let me see. Benedict, you said you can't see the solver in my data tab. All right, so that was a question I was waiting for. So some people do not have solver, and the actual way of doing it is to click on File, Options, Add-ins. Here you have Manage Excel Add-ins, so click on Go. And make sure you tick this solver add-in. So if you don't have it, enable it and click OK. And then solver will show up under your data tab. So that's how you enable solver. Yeah, so I was waiting for you guys to ask me how do you get solver to appear inside your Excel. Yeah, hopefully we managed to open, you guys, you managed to get access to this solver tool. Otherwise, let me know in the chat box. So let me just go back to my slides, and I'm going to show you a few examples of how you can use it in another application. So I think you can see my slides now. So you go back down to, so solver works is magic. And if you're lucky, you can get this answer. If not, you get another answer, it's okay. But you can try changing the values to get the optimal solution. So in this case, an answer that's as low as possible is the best because I want to minimize the cost. Yeah. So if you get 45 point something, it's okay. As long as the constraints are satisfied, it means that your answer is correct. So there is not a single answer for this blending problem. It just actually depends on the cost of blending. Yeah. So in this case, a real life application, you just depend on how low you can get the cost to be. Yeah. So I have prepared a few extra credit questions where I will try to modify the problem a little bit and see how you guys can solve it. But if you want density to be not more than 750 instead, can we still use the same model? So just now I set the density to be more than. So now I have to set to less than. Is it possible to do that? So how do I do that is, let me go inside my Excel here. All right, so I go back to the sheet that I just used just now, and I click on solver again. If you remember all the last settings that I put in just now. So what I'm going to do is I'm going to click on this constraint, F25, H25, which corresponds to the density, and I click on change. I change this value to less than, okay, and then I just solve. So I get a different answer. This is actually lower than the previous answer. Yeah, so this is how I modify the solver inputs to get a different answer. And this is a good thing because you don't have to reset the whole solver every time you want to change. So you can do a lot of trial and error using solver because if you remember your settings previously. So if I just go and click on solver again, you can see that it remembers my old settings, plus it has changed the density constraint to be less than. So this is how you use solver. Yeah, it will save you. It can save all your functions. You can click on load or save here just to export these settings, or you can click on reset to just make it disappear. So please don't click that. And let me just go back to my slides, and I'm going to show you a few other possible applications for the use of solver. So you can see that you get a 49.3 as your problem here. So a few things I want to talk about solver is that first is the optimization problem formulation is important. You must be able to write the problem that you want to solve in an objective function. You must have something that can be minimized or maximized or equal to 0. And you must choose the correct solver, linear or non-linear. So if you look at the solver, you have 3 choices. The first is a GRG. This is for non-linear problems. Simplex LP is for linear problems. And the third one is for more advanced applications where you have a lot of constraints. But for most cases, using either the GRG or the simplex LP will be the best way and easiest way. The initial value matters. If you try 1000 as initial value, you get a different answer. And special cases, you can go in, you can make the constraint be an integer, int, bin, binary, that means either 0 or 1, and different, that means you want all the values to be different from each other. You can set it this way. But I think most cases you won't be using it. Just let you know if in case you encounter this problem. So before I continue, let me know if any questions on solver. So Bianca, back to you.
Hi, Region. So as of now, there are no new questions at the chat box, but we encourage the participants to take the time to ask those questions. So we have a comment here. It will be helpful if we could get this presentation after the webinar in case we have to refer facts and features again.
Thanks, Gatnadeep, thanks. Yeah, I will provide the presentation after the webinar, don't worry. I understand that it's sometimes a lot to take in, right? But I will encourage you, you can try your best to follow along and just to refresh your memory in case that you have forgotten by the end of the webinar. Yeah, so try your best to follow along, and I will send you a copy of these slides later on. So thanks, Bianca.
All right, so another question. When do we know when to use linear and nonlinear solving? Are there cases for each?
Good question, very good question. How do we know if the problem is linear or nonlinear? So let me just go back a few slides here. Let me just go back a few slides here. And okay, let me go back to this slide where I formulate the problem inside solver. So how do we know that the function to be solved is linear? So the function to be solved is linear if in the objective function and in all constraints, the power of the variable to be solved is 1. That's it. That's what I mean by linear. So in this case, for example, this equation, the mutual cos is equal to x1 multiplied by cos plus x2 multiplied by cos plus x3 multiplied by cos. So x1, x2, x3 are the variables to be solved. So in this case, these are linear. And this is a linear problem. If this were, let's say, x squared multiplied by cos, it will be a non-linear problem. So that's how I define it to be linear and non-linear. For a linear problem, the function and the constraints all must be linear. If I have at least one non-linear constraint or function, the whole problem will become non-linear. That's it. Hope that answers your question.
All right, so Nico, please let us know in the chat box if that answers your question. Meanwhile, we have another question. Is there a limit on the number of constraints?
Is there a limit on the number of constraints? The answer is no. You can go up to 100 constraints, 500, 1000. The limit on the number of constraints is the limit on the power of your computer before it blows up because you put in too many constraints. I would say that's it. I'm saying in a joking way, but there's no effective limit on the number of constraints. I have solved problems where there are 100 constraints. It's perfectly doable, but it might take some time for the solver to run it to completion. Yeah, hope that answers your question.
Yes, I think, Regine, yes, thank you. So another question is it possible to get an error as an answer?
Good question. Is it possible to get an error as the answer? The answer is no. Solver will always give you the best answer you can find. Let's say you have 5 constraints, but you can only find an answer that can satisfy 4 of the constraints, then it will give you the best answer. It will give you the best answer that can satisfy as many constraints as possible. But usually you will fail to get the correct answer if you have 2 situations. The first situation is where you have a constraint that you have 2 constraints that contradict each other. For example, let's say I want to solve for the variable x. The first constraint, x is greater than 0. The second constraint, x is less than 0. Then the function will not work because there is no value that can satisfy both greater than 0 and less than 0 at the same time. Yeah, that's one way that you can get an error. So if you have this kind of error, you might want to have a look at your constraints to make sure they do not contradict each other. The second is when your function is not constrained at all. For example, let's say I said, I want to maximize the value of x, and my constraint is x is greater than 0. In this case, I will not have a good answer because x can go on forever. The function is to maximize x, and the constraint is x is greater than 0. That means from 0 to infinity, any value can satisfy this constraint. So solver will not give you a good answer. It will give you probably some very big number like 3 billion or something, and then it tells you that it will just never converge to a correct answer. So that's the second case where you have an error inside solver is because you effectively you have written the constraints in a way that there is no constraint. Basically, there is no constraint, but you have written in a way that you didn't realize that the constraint is actually not working. Hope that answers your question.
All right, so thank you, Weijan. Another question is it possible to use solver without any constraints?
Is it possible to use solver without any constraints? Yes, but that's sort of not the point of solver. And if you don't have any constraints, most of the time, I would say 99% of the time, you give you a very crazy answer as your answer. I would say that. So usually you want to have some kind of practical limit on how much the answer you want to go. For example, it might give you the answer of 3.6 billion something as your answer. And because technically the answer satisfies the equation, even though in practical there's no practical usage of the answer. Yeah. So that's my answer to that. Hope that answers your question.
All right. Another question is, will the overly constrained equation provide meaningful result, especially if exceed its degree of freedom?
Yes, that's a very good comment and very good question on that. And yes, degree of freedom, the degrees of freedom is an important aspect in the optimization problem. But I'm not going to discuss too much on that because I don't want to be too academic. This is probably something a lecturer will tell you in a university. But it's true, yes, it's true that the degree of freedom will affect what is your meaningful answer. That's true. So we usually try to give the minimum number of constraints that gives us the meaningful answer. So if you have a constraint that you're not sure whether you should be putting in or not, don't put it in. Just try and run the solver without that constraint. If you can get an answer that satisfies the rest of the constraints and is good enough, then that's it. So do not over constrain your solver. But to be honest, sometimes in real life, you don't really have an idea unless you take some time and write it out on a paper or something. You might not realize that you have overly constrained your problem. So sometimes it does take a bit of a trial and error to know how much of is the constraints. But the general rule of thumb is you use the minimum number of constraints to get your answer. Try your best to use the minimum number of constraints. So solver has more freedom to try various values to get your best answer for you. Hope that answers your question.
All right. So to summarize that way, Jan, it means that the lesser your constraints are, the more meaningful the result of the solver.
Yes, correct. Yeah, correct, Bianca. Yeah.
All right. So we have a comment here. Yes, solver will run, but you might not get the answer you want. Example, you might get a negative number as a result.
Yes, good observation there. In fact, I think I have run solver a lot of times in the past year, and most of the time I've gotten a negative answer for an equation that is not supposed to accept a negative answer. So that's true. And usually we will put in the non-negative constraint. That means we will, for example, on this slide, you can see that I have x1 greater than 0, x2 greater than 0, x3 greater than 0. And this is why I set this constraint. Yeah. So usually we have a non-negative constraint where we will set whatever results that we do not expect to be negative to be greater or equal to 0. And the same for vice versa. If you have a value that must be negative, we will set the constraint to be less than or equal to 0. So this is one way to make sure that you get a meaningful result. And usually the non-negativity constraint is a very important part of any optimization problem. Yeah, thanks for the observation. That's a very good observation. And I really love to chat with you guys on these kind of topics. Yeah, back to you, Bianca. Thank you very much.
All right. Thank you as well, Wei Jen. So just a few more comments from Miss Regine. So if you won't add constraints, then that would happen. You will get negative number as a result. And then there are also constraints to make your values to be integers.
Yes, correct. Regine, you're correct. There are constraints to make a values integers. There are constraints also to make a values a binary number. That means either 0 or 1. There are constraints that make sure every value is different. So these are the three types of special constraints that you can put in as I'm showing in my slides. And if you have some time, you can play around with it and see if it gives you a correct answer, or a funny answer, or a weird answer. It's pretty fun once you get the hang of it. So I would say that's true, and you can experiment as much as you want with a solver. Yeah. After all, you already paid for this software, might as well as use it to its best, right? Thank you very much for the observation.
All right. So thank you so much for your observations. I think that would help us make our solver provide more meaningful and effective answers. So if there will be no more questions, maybe we could proceed with our next topic.
All right, if there are no questions, maybe I'm going to talk a little bit about our next topic, which is VBA, and this is going to be the main crux of what we are going to do today. Yeah, so let me just move my slides here. So you can access VBA in Microsoft Excel. And this is a window that's going to show up when you open your VBA IDE. IDE means Integrated Development Environment, and it's how you are going to do your coding for VBA inside Excel. So for now, let me just go to my Excel. I'm going to show you how to open it. I believe most of you guys have not actually tried it before, but if you have, good for you. So let me just share my Excel screen. All right, so you can see my Excel screen now. And how you access VBA is by clicking on your developer tab. So you have a developer tab here. And click on Visual Basic on the far left. So Visual Basic will show up in the new screen. So this is the Visual Basic IDE that I just shown you. And so one question you might have is, I don't have this. I don't have the developer tab. And so if you need to turn it on, you click on File, Options, Customize Ribbon. And on the right side, you see Main tabs. Make sure you have tick. Make sure that this developer tab is tick. There is a tick inside this box and click OK. Then developer will show up. And that's how you access the developer tab and Visual Basic via the correct way. Or if you know the shortcut, you can just press the shortcut key on your keyboard, but I'm not going to tell you that just in case. So I'll just show you the correct way of accessing a Visual Basic IDE. So you can click on this, and it's going to show you the Visual Basic IDE. So, wow, looks complicated, right? There are many things here. So I'm going to just point out to you. So you should have this window here. Okay, this is probably how it looks like on your screen. So the left-hand side, we have a pane here. This is the project tab where it shows all the open files that you have. So you have opened multiple files. You will see many names here. So this VBA project, so if I double click this one, it's going to show all the objects that are present in the, all the sheets that are present inside this file. So let me go to example 5, let's say. So there's nothing inside there. Here's a property. So I can create I can change some properties. For now, we are not covered too much because it's a bit deep and a bit complicated. So this is the general window where we can do some coding here. We are going to write our coding here. Immediate window is where we run some code that we want to know now. So basically, an immediate window, I'll show you later how we can do that. And the locals window here will show you the values of certain variables that we use. So my first question, so one question will be, I don't have this window. I don't have that window. How do I access it? So click on View, and you can see code. So code is for this window. Object Browser is for this window. Immediate is for this window. And Locals is for this window. And then we have a Project Explorer for this window. This one right here on the left side, and Properties on this. So I can just turn it off by clicking it. I can just turn it on by clicking it, and then you see it appear on the screen in case you have closed it. Yeah, so if your window looks different from mine, don't panic, because I have rearranged it a little to look nicer. That's why it might look not exactly the same as your window in your Microsoft Excel. Especially if you are the first time opening it, it might look completely different. So don't panic. Yeah, we are going to use the code window. So real code, we are going to use the code window and the immediate window for our next what do you call this example. So make sure you have these two open. So I'm going to go back to my slides, and let me just go back here. All right, so if you have any trouble opening any window, please let me know in the chat box and I can demonstrate again during the example. But before we jump into programming this VBA, it might be helpful to know exactly what is in VBA. So VBA contains 4 components: variables, operators, functions and subs, branches and loops. So these are the 4 main components of VBA. And just a simple explanation on what each one does. So the variable actually is a container for storing a piece of information. Operators is how I manipulate variables. Functions is how I run operators to manipulate variables. And branches and loops means on during what situation I want to run which function, or how many times I want to run a function. So these 4 components are linked together in order to create a useful function that can help us. Yeah, we are going to use all 4 together to help us. So let me just go into the first variables. So there are many kinds of variables in VBA. There are at least 30, I believe. But just not to bombard you with too much information, we are going to just focus on a few important ones. So a variable has a type name. The type name is basically what variable it is and what is stored inside the variable. So let's say we have the string. The string basically is any text. So hello world is a text. I love VBA is a text. A is a text. And empty space bar is also stored as a string. And a string is usually we define a string by using the opening and closing quotation marks. So if something is enclosed in the opening or closing quotation marks, then it's called a string. Next is integer. So we can have positive, negative, 0. Integers, but we probably know what it is. A Boolean variable is something that contains either true or false. So the variable is either true or false, that's all. So for numbers, we can have single and double. Single means single precision floating point. And the exact definition, I'm not going to bore you with that. It means that there's a certain limit to how big the number is. But for almost any application, the limit is so big. It's like 1 to the power 100, something like that. So it's not going to be a big issue. But the double number is more accurate than the single. So usually I'm going to use double in the examples in this presentation. We can have a variant variable type, which is can accept either string or double. So let's say I'm not sure later on which one I will be using. So I can use this variant as a variable. An array is a collection of elements. It can be either one of the above, and the array is a more complicated piece of an example, which I will not use today. And we also can have an empty variable. If you have not defined the variable, it's considered as empty. Yeah, so there's a lot of talk, a lot of theory. So let me just show you if I can let you know a little bit about variables. So let me just go back to my Excel here.
Hi, Region. Just a request. Could we go a little slower with
Thank you. Yeah.
Yes.
Yeah, I go a bit slower. It seems like maybe there's a bit of lag or something. All right, so can you see my Excel screen now? So I'm opening the Visual Basic for applications.
Yes.
Yeah, sure. Okay, so let me just show you how variables work in the immediate window. So I'm going to use this immediate window. So I'm going to make it bigger just to make it easier to see. And you can just use it as a mathematical operators. For example, x is equal to 2. If I type like that, then it will store the value of 2 inside the variable x. And I can like type in type name, open bracket x. And Visual Basic for applications has a special tip where when you are typing in something, it will show you a tip of what you are supposed to type in the screen. So in this case, type name, I need to type in the variable name here. So the variable name here is x. I'm going to type x. And then I just press enter. Nothing happens. Why? Because I did not ask it to tell me. So Visual Basic is sort of very manual kind of language. If I want to know something, I need to type in print, say x, and then it will show the value of 2. So this is how I ask Visual Basic to tell me something inside the immediate window. So let me just do it again with type name, bracket x. So in any function, you must have an open and close bracket. You must have open and close bracket. So in this case, I have an open and close bracket here. I must have one outside. So that is how I type in anything. So I just click and press enter. It tells me that 2 is an integer, which is true. And I can link two variables together. Let's say x plus 2, it tells me the answer 4. Print x minus 2, it tells me the answer 0. And I can, let's say, type in type name, print type name x minus 1.5, and it will tell me the variable type is double, because this is not a decimal point number, and by default it goes to double precision as a variable type. So, and let me just try a few other things. So let's say you can print, let me just let y equals to true, and then I just type in print type name. Oops, sorry, I forgot to type in this x. It tells me it's an integer. Why? So because I refer to x, right, it's defined here. So let me just copy this and paste this, and then see if I can change this to y. So you can manipulate anything inside this window, so it makes it easy if you want to copy paste from somewhere. And I can just type enter, and it shows as a Boolean variable because it's a true variable. So I can just print y, and then you will say true. So this is a very simple introduction to what the variables inside VBA is. So if you have any questions, please let me know in the chat box and I'll try to answer them. Otherwise, I'm going to go to the next one. So are there any questions? Otherwise, I'm going to answer them later on.
All right, so we just have a few quick questions here.
All right, so let me just go back to the slides. Okay, so there's a lot of discussion on what are variables, but to be frank, variables alone are not useful because you have to manipulate them in some way. And how do we manipulate variables? We use operators. So what are operators? The easy way to describe it is basically plus, minus, multiply, divide, and comparison operators. So let me just go through this. So the top two are the mathematical operations that we usually use here. Equal is a assignment variable, which is I want x is equals to 2. I will type in x equals sign 2. Not equal to is represented by these two symbols. You have less than, greater than, less than or equal to, greater than or equal to. And for Boolean variables, you have the special and or. So later I will show you how to use this. And then we have a not, which is give me the opposite answer of what I just found out. So let me just go back to my Excel. And I'm going to go very slow here. So I hope you guys can follow that. I'm going to delete everything in my immediate window just to make it look cleaner. And I'm going to assign a few variables. Let's say x is equals to 2, enter. Y is equal to 3, enter. So I can now print is, sorry, I think I mistyped this. This should be y. Let me just try again. X equals to 2, y equals to 3. And now I'm going to print 3 greater than 2. So I can do comparisons inside the print function. And it's going to say true because 3 is bigger than 2, right? So let's say print y bigger than 2. I get true. Print y bigger than x. I get true. So this is how you use a simple comparison operator. Let's say just say print y equal greater than or equal to 3. You get true. So this is very simple introduction, and we can do some addition, subtraction, and so on. So print x plus y equals to 5, print x to the power y equals to 8. So remember that when you do any operations, it will not affect the original value of x and y. So let's say I go back to x, it still shows 2. I go back to y, it still shows 3. That means whatever operations that I did previously, it will not affect the value of x unless I reassign a new variable. Let's say x equals to 4 now. And then when I print x, it's now equal to 4. And I print x equals to x plus y is now equal to 7. So you realize that it does not update any previously defined answers. So this answer is 5, is still 5. The new answer is 7, it doesn't affect the previous answer, even though I've changed the value of x. So that's an important point to mention, because sometimes you don't realize that you changed something and it still gives you the old answer. or sometimes you didn't realize that you changed something and it gives you a different answer than what you expect. So this is usually what you want to look at. Yeah. So any questions you have, please type in the chat box. Otherwise, I'm going to do a little bit of logic operations here. So let's say we have x equals to true. So this is a Boolean variable. And maybe let me just delete this so it looks nicer. And let's say print x. So it says true, all right, nothing special. So y equals to false. So now I just print y, it says false. And for Boolean variables, you can use the special operators and or. So let me just try x and y. So let me see what happens. It says false. So the operator and will solve the logic operation by thinking if there's one value that's false, it will just say false. That's it. Sorry. So let me just try print x or y. It will just tell me true. So this goes back to if you learn about logic or computer science, something like that, then you understand what this means. And you can change the order of operations by enclosing them inside brackets. So in this case, it's going to solve this logic operation first, and then that value will be compared with true, whether the OR operator will compare it with true, and then you get the answer true. So this is how you use Boolean variables. So I'm not going to go too much into this logic because it's more of a computer science thing, but just to have a basic understanding of how you operate, manipulate this kind of Boolean operators. So let me know if you have any questions, and I'm going to go back into the slides, just not to go too deep into logic operations. And let me just go back here. All right, so the next thing we have on our list is functions and subroutines. So a subroutine is also just called a sub. And some people confuse these two. A function is something that has input and output, and then can be called. A sub is an only input, no output, but can be run. And the sub is usually what we call macros. If you have heard of the word macros, it refers to a sub. So this is actually the name inside VBA. A function can be private or public, and it's recommended to declare all variables before use. And it's actually normally optional, but I would recommend you do that. If you need to use any variables, it's recommended to declare them first before you use any, just to make sure that you don't accidentally change the value of variable or you use the wrong variable name. So this is later I will demonstrate how we use this. Then we have branching and looping. The conditional branching means that if else. If something happens, do something. Otherwise, do something else. Otherwise, do something else. Whereas for loops, we do something a number of times. Depending on how you set up the loop, you can do it 10 times, 100 times, and so on. So let me demonstrate the third and fourth elements using a very simple game. Have you guys seen this kind of post before, some motivational post where you have to find out which word actually gives you an answer of 100. If you add up all the letters inside the word, and each letter represents a number according to which letter is it in the alphabet, and then you get a total sum here. So, and obviously it's very tedious to calculate every word individually, but we can do that using a simple VBA code. Let me just show you. But before you jump into any programming, any coding, it's nice to take out a piece of paper and just sketch out how you think the problem should be solved. So in this case, I'm going to, let's say I use the word attitude here. I'm going to separate out all the letters into the numbers. I'm going to add up the numbers, and I'm going to report the final answer as 100. So again, I'm going to separate out the letters. I'm going to convert each letter to its number. I'm going to add up all the numbers together, and then I give me the final answer of 100. So this is what I'm trying to do. So let me just show you how to do it. Share here. I'm going to share my Excel here. So you can go into example 5 where the code has been prepared. And so if you have any trouble, please let me know because I don't want you guys to get lost. So that I'll just show you step by step of how I'm going to do that in my VBA IDE. So I'm going to delete everything here. And so usually how we code in these functions is that we use a module. So let's say I go in here, Microsoft Excel objects, I can right click, insert module. So you get a new module folder and a new module name. So in this module name, I'm going to give it a name, let's say example 5, just so I know what am I doing at. And the good thing about a module, why I don't just put it inside this sheet is that I can import and export them. So in case I need a file to be shared with my friends, I can just export the whole module and they can import from their Excel and then they will have the code. So it's pretty easy to share your code with other people. You don't have to have special software or special methods. Just click export, and then it will save it somewhere as a VAS file, and then you can just send it to your friend and they can import it and you have your code. Yeah, so let me just code this function. So you have this option explicit here. I recommend you delete it. Later I'll explain what it means. And I'm going to introduce a function which is going to be called function. And I'm going to give this function a name. So let's just say I call it word score, because I want to know the score of each the word, right? And for a function, I have to define it by open and close brackets. So this is how I define a new function. When I press on enter, it will show end function. That means VBA has known that I'm trying to define a function, and anything that I want to define inside this function must be between these two lines. So I can put anything here, I can make it as big as I want, but I must define everything between these two lines. And just some sharing on the function name, usually we will put in capital letters in the middle of the word so that it becomes easier to read. Yeah, so you can put in a whole capital letter or small letter, it's okay. But this is usually the way that we write it in. And what I'm going to do is I'm going to define a few variables. So I'm going to define by typing the word dim, D-I-M. And then the variable name. Let's say I call this variable word as string. So you can see as I type, VBA will show me an example of what I can fill in. So I can also click here, or I can just type in manually. So I'm going to use another variable to determine the position of the wordings, the letters as I. Right? Nothing much. But for I think it's better to put it as integer because it's a number. And I'm going to just go through here. So I'm going to define word as the word attitude. So because word is a string, I must enclose it in quotation marks. And I'm going to use a loop here. So this loop, what happens is that this loop is going to read every letter as A, give me and tell me the score of each letter individually. So I'm going to use a for loop here. For I equals to 0, for 1, 2. So this word has 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 letters. So I'm going to put like this. And for for loop, I need to put in the next as the ending. So I must define anything I want inside the loop to be inside this for and next. So what happens now is that I'm going to ask VBA to detect what is the letter inside and tell me the letter. So I don't want to jump immediately into telling me the score. I just want it to let me know what is the letter here. So I'm going to define a new variable called, let's say, current letter as string. And in here, I'm going to use it, I'm going to type in current letter equals to, I'm going to extract the letter from the word. And the way I do it is by using the function mid word I. So that means take out the number I letter from inside this word. And usually if I have a sub function inside another function, I will just tap it just to make it look neater and easier to see. And after I have this current letter, I'm going to just ask it to tell me what is the current letter. And just to tell you that in the code window, I have to type in the word debug.print. I cannot just type in print because because the print keyword conflicts with a real print application. That means actually printing out your Excel sheet. So in the this code window, I have to type in debug.print. And I'm going to there's a run button here. So let me just try to run it. And it tells me, it gives me the word, but it tells me the whole word from the starting of I to the end. The reason why is I forgot to type in one parameter here. You can see mid, it tells me string. There are 3 arguments. These are what we call arguments that we have to fill in. The first is the string to be cut out. The second is where to start, and the third is length. So in this case, I should have typed in 1. That means I only want 1 letter. And I'm going to just delete this. And let me just run this again. And you can see that it tells me the 8 letters of the word attitude. So now let's convert this into a number. So the way to do it is to use the keyword ASC. So let me just use another variable. Let's say dim current score as double. So we are going to use this score as a double. And I'm going to take out the score here by using the keyword ASC. So current score is equals to ASC bracket current letter. And now I don't want it to print out the current letter. I can just type in a single quotation mark in front of the line. This will turn the line into a comment. And a comment is something that is not executed. That means it will just ignore this line. Yeah, basically, it will just ignore this line. So I don't have to delete it in case I need it later. So I can just leave it like that. And then I'm going to add in a new line just to print out the new score and to see that if my code is done correctly. So debug print current score. So I'm going to run it. Oops. I get some numbers. And the numbers are not what I wanted. So what happens now? You realize that A is supposed to be 1. A is supposed to be 1, but it tells me 65. So, and you can see that this is actually a linear increase. This is because of the way Excel codes it. A has a value of 65. So what I'm going to do now is a cheap, easy way. I'm just going to minus 64 out of this current score. And let me just try it again and run it. So now I get the score that I want, yeah? So now I can now do the adding. So I'm going to, if I'm going to add up this score, I will need one more variable. Let's say dim total as double. And I'm going to initialize it by first allowing total to be 0. And then I will do total equals to total plus current score. And then I'm just going to show what is the current total, just to make sure that it is correct. So debug print total, and I'm going to just run it. Let me clear this first, and let me just run it. Oops. Okay, so you can see that the score is added up correctly, and I get 100. Yeah, so we have successfully, I would say we have successfully done this function correctly. So congratulations. But the problem now is, how do I put it back into Excel? Because obviously I don't want this function to be just here, and I want it to be inside Excel. So as I said before, a function is an input. So to have an input, I have to fill in something in the middle of these 2 brackets. So I'm going to just fill in word here. And I'm just going to comment out this word so I don't have to fix it with attitude. And I'm going to delete it. And just in case it crashes, I'm going to save it. But when you click on save, you say these following features cannot be saved in macro-free workbooks. So this is one thing I want to point out. When you save any Excel file with a function inside it, you must select the macro enable workbook. If you are using a newer version of Excel, I think after 2003, I think you have to select this file format in order for your Excel code to be there. Otherwise, it will just disappear. So I'm going to save it here, and I'm going to go back and see if it works properly. So remember the function name word score. Remember the name word score because you are going to use it. And I'm going to go back into my Excel, and I'm going to use this cell to calculate the score for each word. So what I do is I run it as any Excel function. I type in equal word score. You can see that the function word score appears automatically once you type it in. Open bracket, choose the word, enter. Oops, I should have removed this, sorry. And let me just click on reset, and then I go back to my Excel again, and I just recalculate it. So I get the answer of 0. What's wrong? The reason is that I have calculated the value correctly. Yeah, as you can see in the debug window, in the immediate window, I've calculated the value correctly. But what happened is I forgot to assign the total to the output. A function needs to have input and output. In this case, this word is the input, word score is the output. So what I'm going to do is before the end function here, I'm going to assign word score is equal to total. That means after calculating, I want it to save it inside this variable called word score. Otherwise, I will not have the answer that I want. So I go back into Excel, I'll save it, and then I press enter. So I get 100. Yeah. So this is how you program a simple function inside Excel. We took 5 minutes. It's not that difficult, and it's actually pretty easy once you get the hang of it. But you do have to have a little bit of trial and error to see some errors that might appear. And just now I purposely shown you some errors that usually appear when we try to do a function for the first time. Yeah. So do you have any questions? Please let me know in the chat box. And if not, I'm going to show you one more example just before we move on. And I'm going to just drag this down to the second word here, knowledge. And if you calculate it manually, you realize that this answer is wrong. Have you guys any idea why? Let me just go back to my code and we'll do some investigations and see what happens to the code. So the problem here is that I have set it to calculate only the first 8 letters. The problem is that knowledge has 9 letters. So I've forgotten to add in the last letter. So the correct answer should be 96. So I can manually type in 9 here just to make it calculate for 9 letters, or I can just put in a simple way to represent the length of the word by typing LEN. LEN will always give me the length of the word no matter what word it is. So if I replace the code like this and I save it, go back here and run it, I will get the correct answer of 96. So I can just drag it like any Excel formula, I just drag it, so I get all the correct answers. Yeah. So I think Bianca, maybe we can do a Q&A session here just to see if anyone has gotten lost or has some trouble keeping up. So maybe if you have any questions.
I think we have a couple of questions in the chat box. So first is here. When trying to run the program, it asks for the macro name. It can only be run if it is highlighted in the program or code first.
Yes, it is correct. If you accidentally selected outside the function, it will not know, Excel will not know which function to run, so it will ask you. And because in the IDE, you can only run macros or subs. So functions are not supposed to be run inside the IDE. So if you want to run it, you must click in somewhere inside the function and then click on run. You must click inside the function before you can click on run. Otherwise, you keep showing the macro name. Yeah, so I hope that answers your question.
All right, so Aaron, perhaps you could give it another try and let us know in the chat box if it already works. Another question is from Philip. The code syntax and data types are very much akin to VB6. Can we access the low-level interface of a microcontroller for data mining, for example, DLL and XMLs? Excel is an excellent data processing software to manipulate the raw data generated from temperature, pressure, and sensors. Normally, this can be viewed real-time in DCS and SCADA. Is VBA optimized for such low-level interaction? It's easier to do in C or C++ 15 years ago.
Thank you, Bianca. That's a long question. All right, let me start. VBA is derived from Visual Basic. So it's true that you will have many similarities with VB because VB is Visual Basic and VBA is Visual Basic for application. So it is a simplified version of VB. So you will expect the syntax and coding to be very similar to Visual Basic, but it's much easier to use because on Visual Basic, you will need a Visual Basic Studio and you have to write out whole program and so on. In Excel, you can have something, Excel sheet that you can directly interact with the sheet. And that will make it easier for you to run anything. About interacting with microcontrollers and PLC and so on, Excel is not really equipped to do that because Excel actually runs, is a spreadsheet program. It actually is designed to be used for accountants, statisticians, and so on. But there are third-party add-ons that can allow you to import that data into Excel, and then you can do whatever you want, statistical analysis, standard deviation, process control, even maybe statistical process control even. But you do have to find a way to import that data into Excel in the first place. So that's how I'll answer your question. I hope that answers your question.
All right, so for the next, it's not actually a question, but a request to, if it's possible, to type the whole, if you could type the whole program into the chat box, just to save people the time of typing the commands.
Yes, I can do that. Let me just try and see how I can do that. Let me just.
We could also try it as well in our own Visual Basic applications.
Yeah, you can see in the chat box, but I have to tell you that it's a bit difficult to see and you can't copy directly. So the only thing you can see is you have to type it out yourself. So it might be not that easy for you. So I have typed it in the chat box, but I'm just showing on the screen just in case it's easier for you to look at the screen. So I'm going to delete this and you can see. So I'm going to leave it out for a few moments in case you have any problems and you can have a look. Yeah, I will provide you with the full code later on. Don't worry too much, but you might want to try it out just in case you see any errors, and then you can tell me the errors and I can help you to see if you can, we can prevent those errors from happening. Yeah. Thank you very much.
All right, so I guess we still have to type it ourselves since we cannot copy from the chat box. Another question is, running the code still asks for a macro name. What should we do again?
Yes, sir. Your function is not supposed to be run inside Excel, inside the VBA. So you have to run it inside Excel. So you realize that when I try to run it, I will get the same error, which is a macro name. But if I run it inside Excel, it works. So if you really want to run it inside here, you really want to run it inside IDE, you have to change the name to sub. You have to change the name to sub. After you do that, you need to remove this word score, and you have to remove the function name, and then you have to remove the function input because a function does not, because a sub does not supposed to have an input, and then you reopen, you re-enable the two define of the words, and then I can run it, and then it will calculate inside the immediate window. So this is how it's done. So a function is not supposed to be run inside the IDE. That's why it keeps asking you for macro name. Macro is a sub, and a sub is only something that you can run from IDE. Yeah, so this is a very big difference. Previously, when I started learning during work, I couldn't differentiate it and I couldn't run anything, and I was very frustrated. So now I know it, so I guess I'll share it to you guys so you guys don't get as frustrated as I am. Yeah, but for now, let me just put this back to the previous settings so I don't get confused later on. This will be function here. Yeah, thanks, Bianca. Do you have any other questions?
Yeah, Yeah, I guess that's it. I think the iteration works. So thank you.
All right,
So
thanks.
for the participants, if you still have questions, please do type in the chat box so that our speaker could address it.
All right, thank you, Bianca. So let me just continue with the next example. And I'm going to, but before I continue with the example, I'm just going to show you one thing. Let me go back to my Excel and look at this word here. This score is not correct. If you have any idea why this score is incorrect, let me know in the chat box. Yeah, if you have very sharp eyes, you realize that 99 is not the correct answer. Or you realize that 99 is not the correct answer. So having which balance is not actually that important. So let me know if you can find out why question 16 is wrong. This row 16, the answer 99 is wrong. So let me know if in the chat box if you have seen it. Otherwise, I'm going to review it at the end of the presentation just to give you some suspense. Yeah. Okay, so let me just go back to my slides for something lighter, just in case you are very bored. All right, so let me just go to the next slide here. If you try it around, you realize that the function only works on uppercase words. It only works on uppercase words. What about lowercase words? Is there any way that I can do that? I'll give you just 30 seconds. First impression, what do you do to make the function work for both upper and lower case words or any combination of the words? So let me know in the chat box, what do you think is the best way to make this function work, no matter either I type in capital, small letters, or mixture of both? Let me know. Right, so you have 10 seconds more. Let me know your first impression. It's okay to be wrong, don't worry. Okay, so the time is up. So let me just tell you the answer now. So let me just go back to my Excel and I'm going to tell you why is this important in terms of having capital and small letters. So I have an empty space here. So I'm going to use this to type in attitude in small letters. Here. And I'm going to copy the function here. I get answer of 0. Doesn't make sense, right? Let me just try to change the one of the letters to capital. Still can't work. What's happening here? What's wrong? The simple answer is that, let me just try and change it here to, let's say, a mixture of this. And I don't get the correct answer. The simple reason is, oops, I must have pressed something wrong. Let me just enter again. Okay, I think some of you in the chat have found the correct answer actually, to be frank. So I'm just going to let the suspense go and tell you the answer. The answer is that in Excel or VBA or many other programming languages, a capital letter is considered as different from a small letter. That means I'm assuming here, for example, that, let me just clean this up again. And let me just send this, just enter again. And I'm going to just send it back the word score to total. Otherwise it's not outputting correctly. And the fact is that you can see that the capital letter A is given the value of 65. So when I minus 64, I get 1. But if I try the small letter, let's say I change the first letter of attitude to this, and then I just try score, you get a very large number. And I get a number of 33. So this means that actually the small letter is given a number of 96. I believe 96 minus, yeah, should be 96. And so what is the best way of treating this? The best way is, of course, I think one of you got it right. I think that's very good, very sharp intuition on your side, is to just make the letter, all the letters capital. Basically, I just force it to be capital. So I don't care whatever word you type in, it's going to be capital. That's it. Simple as that. So let me just define one new variable called upper word. Equals to, and to make a word capital, I'm going to use the function uCase word. And you can see that I accept a string. And for the functions below, I'm going to use the new variable upper word. Upper word. And I'm going to save it. And I'm going to go back in and see if it works properly now. And I'm going to just enter it. And you get 100. So let me just try a combination of upper and lowercase letters. And you get 100. So this is one way to make sure that your function doesn't go crazy when you give it an input that is different from what you expect. So in computer science, we call this defensive programming. Defensive programming. The reason it's defensive is that sometimes we cannot expect the user to do exactly what we want. For example, I might write this piece of code, I send it to you, but I did not mention to you that you must input in capital letters. So when you take it, you try to input in small letters, you cannot get the correct answer. So sometimes in programming, it's nice to predict or at least think of how the user is going to use your code. And build in a few fail-safe just to make sure that in case you get an input that is not exactly the same as what you are expecting, the code will still work. Yeah, so this is a method we call defensive programming. So I hope you guys have learned a lot on this. And Bianca, do you have any questions more? Otherwise, we will continue.
I think, here's a question. Why didn't we dim for upper word var?
Good question here. Why didn't we use dim for upper word? The reason is dim is optional. You don't have to dim every variable, but it is usually considered a recommended practice to declare every variable before you use, just to make sure that you don't accidentally put in something into something that is not supposed to belong. For example, you put in x plus 3 equals to something, and then you type x equals to a word. Then it's going to show an error because Excel doesn't know how to add a word into 3, for example. So in this case, I did not declare upper word. So it's a very good sharp eye that you notice I did not declare that, but it's actually optional in VBA. In certain other programming languages, it is mandatory to declare every variable that you are going to use. So VBA is sort of a more user-friendly kind of thing. You don't have to declare strictly every variable that you use. So yeah, thanks for the observation. It's a very good observation that you realize that I did not actually dim it before I use it.
All right, so yes, you may proceed. There are no more questions in the chat box.
Any more questions do you have, Bianca?
As of now, there are no more questions in the chat box.
All right, thanks, Bianca. So let me just fix this knowledge thing. I think yes. Okay, so let me just get this straight done. And let me just go back to you to show you the last example we have for today, which is how I can use VBA in a real life application in chemical engineering. So because you might be interested to know, like after typing in so many things, after just memorizing all the codes and syntaxes, what is the purpose of learning VBA in chemical engineering, right? Since you say I go seek, I can do everything in go seek and solver, why do I need to use VBA? So this is one situation where VBA is very useful to calculate the heat capacity of a substance. So if you have read like the Paris handbook or other books on Yours Physical Properties handbook, the heat capacity of many substances is given in a polynomial function A plus BT plus CT squared plus and so on. But for this demonstration, I will ignore the rest of the terms because they are usually not that important. So I'm going to focus on 3 terms to calculate the heat capacity of a substance. So let's say Steve is an engineer again. He wants to calculate the heat capacity of oxygen, nitrogen, and CO2. Yeah, just 3 basic gases. So I have helped you to get all the information you need. So I have extracted the 3 values from the NIST webbook. So if you need more values or more accurate values, please feel free to go to the NIST website where they give you a lot of free information about the heat capacity constants. But in this case, I have taken out for you the 3 gases. And I'm going to use this equation up to the power 2 value of temperature, where the temperature it has to be in Kelvin as because of the theory. I'm not going to do too much into theory, but just take it for granted that we are going to have an input of temperature in Kelvin. And I'm going to develop a function CP bracket where I'm going to have the input substance, which is the gas name. So either O2, N2, or CO2, and the degree temperatures in degrees Celsius. So I have to convert it to Kelvin inside the function itself. And this is the function that I'm going to define inside my VBA. So let me just show you how to do this in VBA. So let me just go back to my Visual Basic for applications, and I think it's not showing properly. All right, let me just, okay, so I think it's now sharing this. And let me just go to example 6, and we can see that I have already provided the information for you, and you can see that I have a few heat capacity calculations that we need to calculate here for O2, N2, and CO2. So let me just do it in a new module. So I have opened my VBA here. I'm going to right click on the modules, insert module. So I'm just going to call it example 6 because I'm lazy to think of new name. And I'm going to clear this immediate window. And I'm going to delete this option explicit here. And I'm going to define a new function called CP with two inputs, substance and degrees Celsius, just like that. And then enter. And I'm going to define a few constants. So I need to define the substance name, which is here, and I have to know the A, B, and C. So a shortcut that I can use is I can just type in commas to define a bunch of similar constants. So I can just put it like this. And then I need to know the temperature in Kelvin. So I'm going to define a temperature in Kelvin, T(S) double. I'm going to say T is equal to T degrees C minus 273. And I'm going to just calculate the heat capacity from the formula. So Cp is equal to A plus B multiplied T plus C multiplied T power 2. So it's best if I keep the brackets here just to make sure it doesn't mess up. And it's usually you have to multiply, you have to put in the multiplication sign for every multiplication inside VBA. So now I'm missing the A, B, and C. So let me just type in the A, B, and C values. You can see that Excel will actually highlight this row as red. That means there's something wrong in this row. In this case, it's missing A, B, and C, the constants. So I'm just going to type in here, A is equal to, let's say for oxygen, 0.03235, B is equal to 877 to the power -3. You can type in, you can notice that VBA has helped me to convert it into the decimal point. And I can just type in C as -3.99 to the power -6. And you can see VBA helps me convert it to the correct negative. And let me just see if it works now. Let me just save it. And I'm going to put a comment here. So I'm going to put the single quotation mark as O2. So just to let me know that these three constants are for oxygen. And let me just see if it works properly. So let me just go down here and let me type equal. And when you type in CP, you realize that the function is automatically detected. That means that I've inputted the function correctly. And then I can select the first input is a substance, the second is temperature in degrees Celsius. And then I get something wrong. Let me see. Yeah. Let me just.
Hi, Region. Just a comment. For the function for T, shouldn't it be T deg C plus 273 to show the temperature in Kelvin?
The T here is actually in Kelvin. So I'm supposed to, yeah, correct. Yeah, correct. That's why I couldn't get an answer. Yeah, thanks. Should be, let me just click on stop set here. Let me just try a bit. There seems to be something wrong here, but I can't find why, which is curious because I've never encountered this before. Let me just try and type it again. Okay, I think it detects wrongly. This I have to put in spacing here. So let me just stop it and save it. No. So let me just see if it calculates properly. So I'm going to delete this. I'm going to retype again. CP bracket O2 temperature in degrees Celsius, and yes, I can get it. So let's try the next one. Obviously, this answer is wrong because I have not coded in the constants for nitrogen gas. But the problem now is I have two substances and I have to decide on which substance to use, right? Because I have to have an input to decide the constant because the constants are different for each gas. So I'm going to first type in the constants for nitrogen here, just quickly. You can copy it from the Excel sheet if you want to, but I'm just lazy, so I'm going to just type it like that. Okay, so now I have the function for nitrogen. So how do I make the function choose which constant to use as I am calculating? So I do that by using an if statement. So I'm going to just put in if here. Just to show you one example of the conditional branching. And in this case, I'm going to just use two. So we only have two choices. So I'm just going to have if and then the condition. So substance, if substance equals to O2, then. And then at the end, I must put in the keyword here, and if. And up between O2 and nitrogen, I can just put else. That means it's either O2 or N2. There's no third choice. Yeah. So this is how I would do it. If there were only two choices, I don't have to code in the second choice. I can just type in else. And let me just see if it works properly. And let me just, all right. So now it detects whether it's O2 and N2, and it will give me the correct answer. But now I have a third substance, which is CO2. So I'm going to code in for CO2 here. And I'm going to type in the three constants for CO2, 24.99735. Right, so I have three constants here. And now when I have three choices to select from, I will need a third statement. So I leave the else statement here. I will need the second statement called else if, written like this. And let's say substance equals to N2, then. So this is a way that how I make three choices. So Excel will first check if the substance is O2, then you will use the three constants. Otherwise, it goes to the next one. If it is N2, you use the three constants. Otherwise, if it's something else, it will just use the three constants here. So this is an easy way of doing conditional branching. And let's see if it works for the third one, CO2. Let me just drag it here. So I get a value error. So what's wrong here? The reason is that this is not a number. This is actually written at 300 Kelvin. So what I can do is I can just key in the 300 Kelvin equivalent inside the function, which is about 27 degrees Celsius, and then it will work. Yeah, so it does very strictly require you to follow the required input. So in this case, actually, I could have like created an error message that shows please input a number in temperature, and it will work properly as well. But in this case, I make it simple. I'm just going to fix it by typing my own temperature inside the box here. And any function that you define can be used as any Excel function. For example, here I want to calculate the CP of this mixture. I can just type in, let me just, the percentage of CP of O2 at 25 degrees Celsius plus the percentage of CP N2 at 25 degrees Celsius. And the whole thing I'm going to divide by 100 just to make it correct. And I can manipulate it just like any other Excel function. So you can see that if it's integrated inside your other functions, that you can use it as just like any normal calculation method. Yeah. So I think there'll be a lot of questions from this now. So Bianca, you want to entertain a few questions before we move on?
Okay, so we are now opening again the chat box for any questions from our participants.
Let me know if you have any comments or questions or on observations, like why you get, for example, why I didn't declare CP, why I did not declare this and declare that, and so on. So let me know if you have any questions on that.
All right, so we have participants who are also trying to code. So, Weijian, if you could please go back to the VBA screen. All right, there you go. So we have a question here. Can we define A as cell reference?
Very good question. Can we define, actually, I believe you meant, can we define the three constants A, B, and C as cell reference? The answer is yes, but if you will need a more advanced range object, which I will show you in the final slides, because I don't want to go too deep into this range object. Well, basically, yes, you can set it as a range object where you can, where VBA can actually go into the Excel sheet, find where is this cell and take it out, and then import the value into VBA. Then you don't have to keep repeatedly, retyping it every substance that you have. And that's actually what I do in my working life. I do have a code that automatically detects all the constants inside the sheet and just loads it into VBA, and then I can just come up with any CP of any constant, any substance that I want. So yeah, you can do that, but I'm going to show it to you later because it will take quite a long time to explain what it means. So please let's just say I give you some suspense on how to do it. Maybe I'll show it later. Thank you very much.
All right, so here's another question. Can we call VBA functions if we open other Excel files?
Can we call VBA functions if you open inside Excel files? The answer is yes and no. But in this function is no. If you try to run it in a blank Excel file, you'll find that you cannot run the function CP. It will just not exist. Yeah. The reason is you have to see in this project window, you can see that this VBA project, this is the Excel file that's being opened now, which is the worksheet. And you can see that the module that I just defined, example 6, is under this Excel file. This means that I can only access this module inside this particular file. And that is usually why I don't define code inside Excel sheets, because if I define it inside sheet 2, in most cases, I can only access it within sheet 2. And let's say I made a new sheet and I forgot to reassign it, I will just get errors. So the easy way, if you want to access it inside other Excel files, is to keep it in a module, export it into some place, save it somewhere, and then import it into the new VBA project. So that's how you do it if you want to move modules across files. Hope that answers your question.
All right, so any other questions from our participants?
Let me see. Bianca, let me know if you have any questions. I'm going to take a drink. Been speaking nonstop.
All right, okay. No problem.
All right, please let me know if you have any questions or you have some trouble trying out this coding. And the first time is always the most difficult, to be honest. But after you do it first time, you realize that it's actually pretty child's play for the next second or third time and so on. But let me know if you have any errors that you face, any weird situations that appear, and I'll try my best to solve it for you.
Okay. So for those who still have questions, you may type in the chat box so that Legion could address them.
All right, if you don't have any questions, maybe I'll just proceed to the ending of my presentation. This is the last example after all. if that's okay with you.
All right. So before we proceed to the last part of your presentation, there is another question in the chat box. What was the formula at cell C32 to calculate um, the specific heat of the mixture?
C32, let me just click the cell for you to see. So basically, I just multiply the CPs by their mole fractions, and then I just divided by 100 just to get the average mixture CP. So this is actually not perfectly correct, but for the purposes of this demonstration, I'm going to assume that there's no enthalpy of mixing involved inside this mixture. I'm going to assume an ideal gas mixture. So I think I've shown the formula here. Hope you can see it.
Yes, we can see it. Sorry, I stand corrected. It's heat capacity, not specific heat. All right. So any other questions?
Another thing that you might be asking is, what if I don't get exactly the same values as this value shown on the screen? Is okay, because I actually set some tolerance in the grading. So if your value is not too far away, you will get the same answer. It does depend on how accurately you type in the constants for A, B, and C. So don't worry too much about that.
All right. So if there are no more questions, perhaps we could proceed with the next part of your presentation, and then if there are questions, we could address them after the last part. Region.
Yeah. Okay. So if that's the case, let me just continue to the end, and we can leave the questions for the last, the best questions perhaps. So let me just go back to the slides here. All right. So then we have discussed a bit about how to use how to calculate mass balances in Excel, and this is probably a simple example of an energy balance. If you have the heat capacity, you assume the heat capacity is constant almost a certain temperature range, you can just calculate the enthalpy of any stream using the heat capacity. But is there a more accurate way to calculate heat capacity enthalpy? So I'm going to leave this as an open-ended challenge question. Return to example 3. Assume that the inlet flue gas enters at 600 degrees Celsius. After mixing with quenched air, what is the outlet temperature? Now this is a real-life enthalpy balance question. The hint here is to set out the formula for enthalpy, where enthalpy difference is equals to the integral of Cp with respect to T. And you can set out a Gaussian formula. The flue gas and fresh air inlet enthalpy is equal to outlet enthalpy if you assume there's no heat loss. And you can do that by changing the outlet temperature. So let me just show you how I'm going to do it. So for this formula, the integral can be written like that, where 298 Kelvin is the reference state. So if you go back to the theory of enthalpy balance, your enthalpy requires a reference state because you are not calculating the absolute enthalpy, but the enthalpy difference with the reference state. So for the same three gases, the same constants, you can just type in this formula. And let me just develop a function Hm with the input, the same input substance and T degrees C, and you can get the enthalpy of that stream, and then you can do an energy balance on that stream. So I'm going to leave it to you guys to try it because it might take some time. Feel free to connect with me on LinkedIn, post the answer and tag me, and I can tell you if your answer is correct. Yeah. And if you want the solutions for this challenge question, do tag or email me and let me know, so I can give you the solution later. I don't want to give it to you now. It's not fun that way, you know. I want you guys to at least have some hands-on experience on trying to do this in a real-life situation. And just before I end this substance, the substance of this presentation, I'm going to go into something that perhaps you have heard before, but not really used in real life. But maybe you have used it, but you might not really know what is it. So have you heard about the term macros here? I think most of you will have heard in some way or other, but macros are perhaps something that you don't actually use before. So I'm going to show you what are macros exactly. The simple explanation is that macros record every step that you take and then replace it when you ask it to. So let me just go to my Excel and we'll show you how to turn on these macros. All right, so I'm now back in my Excel here. I'm going to go back to example, let's say 3C, just for fun. And I'm going to click on the developer tab that I show you how to turn on just now. If you have any trouble showing the developer tab, please let me know. Yeah. So the macros is here. You can click it, it shows nothing because I haven't defined a single macro yet. So what I can do now is I can click on, let's just try something funny, something silly. I'm going to click on record macro. It's going to ask me for a name, and I can even give it a shortcut key. Let's say Control A. I can just invent a shortcut key for it. And I'm going to just give it this name just for example purpose. Click OK. I'm going to select this cell, and then I click stop. So what happens is, let's say I select something else, I click on macros, and then I click run, it will select the cell. So that means that it has recorded our every step, and if you replay that step, whatever that I did exactly, it will do exactly as I did. So let me just record another macro. I'm going to record a macro 2. I scroll downwards a little bit, stop recording, and I go back up. I can click on macros, and let me run this second macro. It's going to scroll down the screen for me. So this is how you use macros. So this is something very silly here, but let me just show you a real application of a macro in example 3C right here. If you remember just now, I've shown you that when I'm trying to get 15% more O2, I'm trying to get 10% more H2O, but when I change the first one, the second answer becomes wrong. When I change the second answer, the first one becomes wrong. But if you have a keen eye, you realize that every time I do this repeatedly, the function becomes more and more accurate. That means the answer becomes closer and closer to the answers that I want. So is it possible to converge both of these values by using macros? And yes, the answer is correct. You can use a macro to converge these values. So let me just show you how to do it. So let me just click on this cell. I'm going to click on macros. Sorry, let me just record a new macro 3. Okay. I'm going to go to data. I'm going to go seek to value 15 by changing this cell. Okay. And then I'm going to click on this cell, go seek to 10 by changing water vapor. And then I'm going to stop recording. So that means it has remembered exactly how I did 2 go seek operations. And if I just click on macros and I run macro number 3, it will just do both calculations again. So let me just show it. Let me just reset the 2 values to let's say 0. And I'm going to show you again how it starts to do it. So let me click on macros, macro 3, run. So it runs the 1 iteration of the 2 go seek operations. So if I have many go seek operations I need to do, can I just do it repeatedly and record it? The answer is yes. And that's how you can get the final answer, the correct answer for both of these situations. And one thing I would like to show you in this case is you can actually draw a button. You can draw a button that you just, when you click the button, it will just run both operations. So let me just show you. On the developer tab, you have this insert. Insert form controls, you have this first one is a button. I can just click and draw one button here. And you ask me to assign a macro to this button. I'm going to assign it macro number 3. Click OK. And then I'm going to click somewhere and click again. It's going to go seek both. Click again, click again, click again, click again. So now I can manage to converge both of these values to the answers I want. So this is a very easy application of macros. You can also use VBA to just tell it to go seek 100 times until you get the correct answer, but that is not that fun, right? So you can just do a macro and you can just get the answer just by repeatedly go seek. But to keep in mind that not every application is supposed to do this. Not every situation can be done. Just in this case, I have designed this question so that you can repeatedly go seek iteratively to get both answers to converge. All right, but after all these discussions, what is macro, how does macros relate to VBA? You'll be surprised to know that. Let me just click on Visual Basic here. And let me drag out my IDE. You realize that in modules, I have a new module 1. I have a new module 1. And then I double click it, you realize that it has created 3 different subs. And inside each sub here is the macro that I just recorded. Basically, every step I did, for example, I selected one cell in macro 1. I scroll down a little bit in macro 2, and I made 2 goal-seek operations, but actually I scroll a bit and I selected a few cells, so it shows like that. So macros are a very easy way to learn VBA, because let's say I want to know how do I tell Excel to select a cell in VBA. I just run a macro, select the cell and record it. And when I open my module, it will have told me exactly how I did that, the code, the exact code of how I select a cell. If I want to go seek a cell, what do? I just record a macro of me doing that, and it will tell me exactly the code of how to do that. So in case I can learn my coding from this way. So it's a very easy way. In case you are unsure of how to do something, just record a macro and there you go. It tells you exactly your VBA coding of how you are going to do it if I were to use it in VBA. Yeah, so this is basically a very simple application of macros that some people don't realize. So let me just share this with you. I hope you will like this, this way of learning. It's a very easy way to learn certain advanced functions in Excel, how to do it in VBA. So let me just save this and go back to my slides, and let's see, I have I think 1 or 2 slides left. So let me just go back into this macro introduction. And finally, what are the applications of using macros to record your stats? You can solve simultaneous equations, ODEs, mass and energy balances I just showed you just now, a cubic equation of state to solve for the gas volume or molar volume or density, any numerical method that needs multiple steps like the golden search method, for example, and basically any iterative or multi-step formula, you can solve it using macros. And so you can revisit and solve example 3C. So I just solve it for you guys, and you can see that this button helps a lot in actually doing these iterative calculations. And I think that goes to my end of my presentation. The key takeaways are you can excel in chemical engineering by knowing how to use Excel properly. You can use coding and solver to solve equations, but you must write the equation in a correct way. Master the 4 elements of VBA. VBA only has 4 elements: variables, operators, function and subs, branching and loops. And that's all, folks. Please don't wait now. If you are committed to learning something new, please strike when the iron is hot and start randomly. Just start coding whatever you can think of. Just start with some simple, fun examples, and before long, you'll be an expert in VBA. So thank you very much, and thank you very much, Bianca. Thank you very much, Bataan chapter of PIChE, for inviting me. I think we have come to the end of my presentation, and I'm happy to connect with you on Facebook, LinkedIn, drop me an email. I'm especially active on LinkedIn, so I'll be very appreciative if you guys can connect me on LinkedIn. You can send me questions. I'll be happy to answer them. And I think it's a final Q&A session. So Bianca, I think I will turn over the stage to you. Thank you very much.
All right, thank you so much, Wei Jan, as well. But before we formally end, we have another question here in the chat box. So have you ever doubted the results of your coding? And did you try pen, paper, manual solving to recheck it?
Let me see. Yes, that's a very good question, and that's a very good concern about using VBA. In fact, it applies to every programming language in the world today, is that you don't blindly accept any answers given by any software without calculating at least one example with pen and paper. And yes, I do that. For example, if I have 10 calculations, I'll usually just pick 2 at random and try to do them on paper. If the answers match with the VBA, then I'm going to say, okay, it's probably correct. And I'm going to continue with the rest of the calculations. So it's basically quite helpful to have to just pick a few examples at random, try to get the same answer as in VBA. If you cannot get the same answer, there's something very wrong with your code. You might want to look at it and revisit it. So yeah, that's very correct, and that's a very good suggestion. It's a suggestion that I will give you. Thanks, Bianca. Any other questions?
All right, I think there are no more questions in the chat box, so I would just like to take this opportunity to thank you for sharing your expertise today to our almost 300 participants who came from various parts of the Philippines, from north to Luzon, Visayas, and Mindanao, and we also have some international participants from India and I think Pakistan. So thank you so much, Wei Jian. And before we end this webinar, we would also like to invite you for our upcoming webinars on October 17. We have a workshop webinar to become an advanced level engineer. And then on October 24, we have a webinar regarding sustainable living, pathways to cleaner energy sources. All right. So just an announcement for everyone. This webinar has been awarded with 2 CPD points. 2 CPD points, I repeat. So please don't forget to evaluate this webinar through the PIChE Academy for you to be able to claim your CPD points. All right. And then before we go, may we ask everyone to turn on their cameras for a simple group picture for everyone who attended this meeting. So come on guys, don't be shy. Please turn on your cameras. Wait, I haven't turned on mine. Okay. So everyone? All right. So for the organizers who will be taking the group photo.
Hi, Wei, can you remove first the share screen?
Yes, so that we could fit in everyone in the screen.
Something na hindi para sa.
All right, I think I remove my screen.
Yes.
Okay. We have 12 pages, so medyo matagal. Okay. 1, 2, 3, go. Wait lang. 1, 2, 3, go.
So 12 pages, we will have 12 batches of picture.
1, 2, 3. One more. 1, 2, 3. Last one. 1, 2, 3. Okay.
All right, thank you so much again, Wei Jian, for this afternoon, and thank you as well to our participants for your active. For those who are asking about the recording of the presentation this afternoon, it will be sent by the organizers through the emails that you used in registering for this webinar. Okay.
Thank you very much. You guys are invited to connect with me. If you have any other ideas about how you can use VBA to make your job easier or your life easier, well, I'm up for it. Thank you very much.
Yes, we will definitely connect with you through the links you gave. Okay, so for the participants, please don't forget to log in the PIChE Academy for the evaluation forms and let us know how we did for this afternoon. Thank you, everyone. So please don't forget to log in at the PIChE Academy website. So the link could be accessed in the chat box. For the releasing of certificates, let me just check with the organizers. When will it be available? For the recorded video, please wait for the email of the organizers to your registered emails. Tama. May question lang, no? How about for non-PIChE members? So, for example, fresh grad, will they still have a copy of their certificates?
Yes, Bianca. So we get a list of all the participants today, and we will check with your emails. And if you attended in this webinar, we will provide the certificate for you.
Okay, thank you. So, may time frame na ba tayo for the releasing of certificates? Usually, ano ang turnaround time natin for that?
We will try to accomplish within the week. But, magbibigay na lang siguro kami ng update doon sa email.
All right, okay. Thank you. So, please check your emails regularly for the recording and the copy of your certificates. For the evaluation form, please, Vince, can you please paste again the link for the PIChE Academy?
For the PIChE Academy, Bianca, I'll check with Sir Abet if available na yung evaluation form. If
Okay.
hindi pa, siguro magre-release na lang ng email kung na-accessible na yung evaluation form.
Okay, so 3 things to check in the email: the evaluation form, the certificate, and the copy of the recording.
Ano ko ni report?